Dear viewers, millions of years from now, the sun will morph into a red giant, engulfing planets and turning Earth into a cosmic marshmallow. But don't panic, join us on a journey through time as we explore the sun's ultimate transformation and ponder the fate of our solar system. The sun has been called by many names. The Latin word for sun is sol, which is the main adjective for all things sun-related. Solar. Helios, the sun god in ancient Greek mythology, lends his name to many sun-related terms as well, such as heliosphere and helioseismology. Our sun is a 4.5 billion-year-old yellow dwarf star, a hot glowing ball of hydrogen and helium at the center of our solar system. It's about 93 million miles from Earth, and it's our solar system's only star. Without the sun's energy, life as we know it could not exist on our home planet. From our vantage point on Earth, the sun may appear like an unchanging source of light and heat in the sky. But the sun is a dynamic star, constantly changing and sending energy out into space. The science of studying the sun and its influence throughout the solar system is called heliophysics. The sun is the largest object in our solar system. Its diameter is about 1.4 million kilometers. Its gravity holds the solar system together, keeping everything from the biggest planets to the smallest bits of debris in orbit around it. Even though the sun is the center of our solar system and essential to our survival, it's only an average star in terms of its size. Stars up to 100 times larger have been found, and many solar systems have more than one star. By studying our sun, scientists can better understand the workings of distant stars. The hottest part of the sun is its core, where temperatures top 27 million degrees Fahrenheit. The part of the sun we call its surface, the photosphere, is a relatively cool 10,000 degrees Fahrenheit. And one of the sun's biggest mysteries, the sun's outer atmosphere, the corona, gets hotter the farther it stretches from the surface. The corona reaches up to 3.5 million degrees Fahrenheit, much hotter than the photosphere. The sun could not harbor life as we know it because of its extreme temperatures and radiation. Yet life on Earth is only possible because of the sun's light and energy. The sun is about 93 million miles from Earth. Its nearest stellar neighbor is the Alpha Centauri triple star system. Red dwarf star Proxima Centauri is 4.24 light-years away, and Alpha Centauri A and B, two sun-like stars orbiting each other, are 4.37 light-years away. A light-year is the distance light travels in 1 year, which equals about 6 trillion miles. The sun is located in the Milky Way galaxy in a spiral arm called the Orion Spur that extends outward from the Sagittarius arm. The sun orbits the center of the Milky Way, bringing with it the planets, asteroids, comets, and other objects in our solar system. Our solar system is moving with an average velocity of 450,000 miles per hour. But even at this speed, it takes about 230 million years for the sun to make one complete trip around the Milky Way. The sun rotates on its axis as it revolves around the galaxy. Its spin has a tilt of 7.25 degrees with respect to the plane of the planet's orbits. Since the sun is not solid, different parts rotate at different rates. At the equator, the sun spins around once about every 25 Earth days. But at its poles, the sun rotates once on its axis every 36 Earth days. As a star, the sun doesn't have any moons, but the planets and their moons orbit the sun. The sun would have been surrounded by a disk of gas and dust early in its history when the solar system was first forming, about 4.6 billion years ago. Some of that dust is still around today, in several dust rings that circle the sun. The sun formed about 4.6 billion years ago in a giant, spinning cloud of gas and dust called the solar nebula. The sun is a huge ball of hydrogen and helium held together by its own gravity. The sun has several regions. The interior regions include the core, the radiative zone, and the convection zone. Moving outward, the visible surface or photosphere is next, then the chromosphere, followed by the transition zone, and then the corona, the sun's expansive outer atmosphere. Once material leaves the corona at supersonic speeds, it becomes the solar wind, which forms a huge magnetic bubble around the sun, called the heliosphere. The heliosphere extends beyond the orbit of the planets in our solar system. Thus, Earth exists inside the sun's atmosphere. Outside the heliosphere is interstellar space. The core is the hottest part of the sun. The sun doesn't have a solid surface like Earth and the other rocky planets and moons. The part of the sun commonly called its surface is the photosphere. The word photosphere means light sphere, which is apt because this is the layer that emits the most visible light. It's what we see from Earth with our eyes. The photosphere is the first layer of the solar atmosphere. It's about 250 miles thick, with temperatures reaching about 10,000 degrees Fahrenheit. Most of the sun's radiation escapes outward from the photosphere into space. Above the photosphere are the chromosphere, the transition zone, and the corona. Not all scientists refer to the transition zone as its own region. It is simply the thin layer where the chromosphere rapidly heats and becomes the corona. The sun's atmosphere is where we see features such as sunspots, coronal holes, and solar flares. Visible light from these top regions of the sun is usually too weak to be seen against the brighter photosphere. Still, during total solar eclipses, when the moon covers the photosphere, the chromosphere looks like a fine, red rim around the sun. At the same time, the corona forms a beautiful white crown with plasma streamers narrowing outward, forming shapes that look like flower petals. The sun generates magnetic fields that extend out into space to form the interplanetary magnetic field, the magnetic field that pervades our solar system. The field is carried through the solar system by the solar wind, a stream of electrically charged gas blowing outward from the sun in all directions. The sun doesn't behave the same way all the time. It goes through phases of high and low activity, which make up the solar cycle. Approximately every 11 years, the sun's geographic poles change their magnetic polarity. That is, the north and south magnetic poles swap. During this cycle, the sun's photosphere, chromosphere, and corona change from quiet and calm to violently active. The height of the sun's activity cycle, known as solar maximum, is a time of greatly increased solar storm activity. Solar activity can release huge amounts of energy and particles, some of which impact us here on Earth. Much like weather on Earth, conditions in space, known as space weather, are always changing with the sun's activity. Space weather can interfere with satellites, GPS, and radio communications. It also can cripple power grids and corrode pipelines that carry oil and gas. Hopefully all of you find these facts amazing. Also, don't forget to subscribe to the channel.